we want to talk about the new module, which is this the SQL standard. I have uploaded the slides for TRC. So, please go through the remaining. There is one important aspect about the tuple relational calculus, which I could not discuss in class because of the power failure last class, but please go through that. It is something to do, very important aspect. It is something to do about safe querying. Some tuple relational calculus queries are called safe tuple relational calculus queries. So, information is there in the slides there. Okay. So, let us get started off with this so SQL, it is also called SQL. SQL is originally expanded as structured query language, but it is actually much more than a query language. So, now we think about it more as a standard. So, that is why the title for the module is the SQL standard. Okay. So, it is an international standard that specifies how a relational database is to be set up, and so the various details about that. How do you define the, how do you create the schema, and then how data is to be updated and inserted into these relations, how data is to be queried, one uniform way of querying the data. That happens to be the principal function of this particular whole standard, and that is why the name originally was called as a query language. And then how it also has constructs for specifying when to start this transaction, how to stop it, and then setting certain parameters related to the transactions. So, how these transactions, if you have a collection of transactions, how should they collectively behave? What is there is something called isolation levels can be set up. So, should these transactions should isolate from each other. These are the various things that you can specify using SQL. And then when data is there in relational database, programs have to access the data and then make use of data, and then also update the data. So, how do programs access data? So, what is how is this programmatic access to data which is there in the database, how is that to be performed? All these things are standardized, and a host of other things are also kind of standardized. So, the advantage of a standard is basically that you get what is called interoperability. That means, if you set up your database and define it using standard SQL features, then in principle you will be able to operate with that from other applications developed in any language. So, and if you want to and you develop it in one system and you want to port it to another system, it should be easy to do that, because the standard is followed. Okay. So, the database management RDBMS vendors, so all the RDBMS management systems, okay, the various RDBMS management systems, Oracle, DB2, SQL, Microsoft SQL Server, MySQL, so many RDBMS systems. So, all of them are required to support and implement this SQL standard. Okay. So, that is when it kind of standards are for enforcing consensus. Standards are essentially for enforcing consensus. So, all of them should agree that yes, these are the features, these are the way we support the features, etc., and that is when interoperability will be possible. Okay. So, of course, due to certain commercial interests, the RDBMS vendors may give some features which are over and above the SQL standard. See, SQL standard says that these are the SQL commands, these are the various features, these are to be implemented, but nobody prevents me from doing a little bit more, right. I can always add frills to my product and then make it more appealing, so to say. So RDBMS vendors might will it is there to their commercial advantage to kind of actually give a little bit more additional features, so that you may get attracted to use those features. But of course, the downside of using these vendor specific features is again portability. So today you are using Oracle, and then you have some issue with the Oracle service or the company or whatever, and then now you want to move your entire application to another RDBMS system like DB2 or some other system. DB2 is supported by IBM, like that. Then what you would expect is that your application, it should be easy for you to port your application into the new RDBMS system. That is what the meaning of interoperability is, right. So, when both these vendors they implement SQL, but if over on top of that SQL, if they have given some features and if you have used those features, then you are likely to get difficulty porting your application from one vendor to the other vendor, shifting your application from one specific system to another specific system. So, the pragmatic advice here is that stick to the standard. The vendors have their own reasons why they may give you additional features, but it is always advisable to check whether is this feature part of the SQL standard before you employ it in your application, in the interest of portability of the application. Okay, so let us move on. Going a little bit into the history of SQL, it is developed by IBM in the early 70s, and then it was actually implemented as part of the System R project at IBM San Jose Relational Research Labs, and that is actually the earliest version of SQL. Later on, of course, it got standardized, and during 1986-89 one SQL standard version came. Then around 92 it was SQL2 has been standardized, and around 99 to 2000 1999 to 2003 there is this new standard that came, which is this SQL3, that includes also object relational features, and the kind of evolution continues. I mean, it is as and when various developments take place in the computing science general domain, the SQL standard also kind of tries to evolve to cater to those additional needs. For example, when lot of developments were taking place in the XML world, so RDBMS standards have reacted and then kind of included additional features as to how you can treat an entire XML chunk as a data item, for example. Now you also have, if you have to deal with large binary objects, then how do you handle them? As multimedia storage has increased, how do you handle multimedia objects as part of relational databases. So many other additional details will need some standardization, and these standards are continuously kind of evolving. So one has to keep up to date. If you are working in the database world, then it is kind of essential for you to keep looking up as to what is the developments in the SQL standard. And this module, I just want to put a disclaimer here that this module covers important principles of SQL. It is not I am not going to give complete syntactical and not even all the features of SQL. SQL is vast standard. So we will touch upon the important features that are relevant for an introductory course like this course, and then so I urge you to pick up lot more information about SQL from the SQL reference manuals. So where is the various components of SQL standard, though we do not okay, we can yeah. So there are various features that can be kind of grouped into some functional groups. So this is the there is this data definitions language so called. So this basically has constructs for schema definition and the relation integrity constraints definitions and views and schema modification. All these constructs that carry out these tasks are all can be thought of as the portion called data definition language. And then how do we specify querying of data in the relational instances, and how do we insert data, how do we update data, all these things is in the data manipulation sub language, so to say. And then what are the SQL commands or features that are required for programmatic access to these relational database systems. So from a high level host language like C, C++, Java programs, how do we access data? So features to, so both we will look at embedded SQL as part of this module, and these are dynamic SQL and embedded SQL are involved in this process of setting up programmatic access to databases. Okay. Now moving on, we also have features for transaction control, commands for transaction control, how transactions have to be started, stopped, etc. And one major module within SQL is the access control, data access control. Data is actually sometimes data is very sensitive data. You do not want the certain pieces of data to be seen by all people, right. You want to put some restrictions, and who are the people who can look at the data, who can update the data, who are authorized to change data, etc. These are access restrictions. So how do we specify these restrictions? So there are features in SQL in order to do that. It is called authorization features. We will not actually study much of these things. Okay. So let us start off with data definition. So far we have been saying there is a relation schema. So how do we actually create a table? So here is the SQL command to do that. So here is the create table command, and then you give the name of the relation, and then within braces you give various attribute definitions. So attribute definition, some n number of attribute definitions, followed by this. So the square brackets indicate optional things. So this is integrity constraints, various integrity constraints we can give. These are also called the table constraints. and we will go into the details about what are the integrity constraints. We have already seen them actually, these are called structural constraints, right. So, how do we specify them, etc. So, this is the create table command, and it has two things, attribute definition and the integrity constraints. Attribute definition basically has the name of the attribute, attribute name, and the domain type, followed by optionally followed by whether it is allowed to be null or not null. So, if you give not null, then it is never allowed to be null. If you do not give this, then it is allowed to be null, and then you can also specify what is the default value for it. So, there is a you can by using this word default and then supplying a value in quotes, you can give. For example, create table example 1, it has A and B and C, these are the 3 attributes. So, A is 6 character length value, it is not allowed to be null, and its default is this all zeros, and B is an integer, C is a single character whose default value is F. So, and there are lots of these domain types. I will not go into full details about this, but most of the types that you are used to in programming languages have their kind of counterparts in SQL data types. So, there are numeric data types, integers of various sizes like integer, small int, and the real numbers, real, float, double precision, and then formatted numbers, all of them are kind of available. So, and then character strings of 2 types, the fixed length character strings and the varying length character strings. So, varying length means varchar is, so the value can have a maximum of n characters, you can specify that, and if it is character n, then it is fixed length, it has exactly n characters and things like that. And in the there are bit string data types also, that means it is a string of bits, and you have again 2 variations, bit varying and just fixed length bit. So, and then date data type, time data type, and a lot of others data types are there. Please look up the SQL reference books when you come to developing the programs. Date is a 10 position format. So, year and then month and day, time has hours, minutes and seconds, etc. So, most of the data types that you are familiar with in programming languages will be available here. Now, let us come to the integrity constraints part. These are also called the table constraints, and what are the table constraints that we are familiar with? Domain constraints, key constraints, and referential integrity constraints. So, domain constraints are in some sense indirectly they are already specified here, because you are giving the data type, right. For every attribute we are giving the data type, domain type. Okay. So, that specifies the domain constraints. And then coming to the key constraints, here is how you can specify the key constraint. So, you use the word keyword primary key and then give a list of attributes. So, what it basically specifies here is that this set A1 through AK is the primary key for the table, and then a table can have, a relation can have multiple keys, and so you want to pick one of them and then say that it is a primary key, and the remaining things you can specify using this word called unique. So, this keyword unique you can use and then say that, so this B1 through Bk also is a key. So, for other candidate keys you will use this word unique to specify that these are also keys. So, that kind of completely specifies as to what are all the keys that the relation has. So, there can obviously be more than one unique constraint, but only one primary key constraint for a table, right. And then here is a how you specify referential integrity constraints. So, the keyword here is to use foreign key and then specify what exactly is the key or keys sorry attribute or attributes that constitute the foreign key, and the keyword references and the relation that that we refer to, and what is the specific attribute in that relation that we refer to. Okay. So, this phrase specifies that attribute A1 of the table that is being defined, let us say R1, is a foreign key, and it refers to attribute B1 of the table R2. Okay. So, we use the word table and relation interchangeably in this module onwards. Okay. So, though there is some technical difference between the results of SQL queries, we will see it later. Okay. So, what does this mean? Specifying this foreign key A1 references R2. You can recall that what this means is that each value of this column A1 in the relation R1, in the relation instance of R1, the relation instance R1, is either null, is allowed to be null, or is one of the values that are appearing in the column B1 of R2. That is what referential integrity constraint is, right? You recall that? So, you could specify, so this is how the foreign key gets specified. So, let us now look at the scenarios as to what should happen if a referential integrity constraint gets actually violated. Okay. So, we can actually specify, while we are defining the table itself, we can specify as to what are the actions that can be taken or should be taken actually if the referential integrity constraint violation occurs. Okay. So, when does a violation occur? A tuple in one relation instance is trying to refer to tuple in another relation. Okay. A violation can occur if the referred tuple does not exist there. Okay. It should exist, that is what our referential integrity constraint means. Supposing you are operating your database and there is a reference from one relation, one tuple from one relation to a tuple in another relation, and for some reason the second tuple, the referenced tuple gets deleted. If it gets deleted, then there is a referential integrity constraint violation. Okay. Or let us say it gets updated for some reason, the actual column value B that is being used for referencing has changed, the value has changed. Then also, see, while referring you are using department number 3, and for some reason in the department number 3, in the department table 3 has got updated to 6 for some reason, let us say. So, then there is also a constraint violation, because 3 got updated to something. So, this can the violation can occur if the reference tuple is either deleted or is modified. Under these two circumstances, a violation can occur, and what we will be doing as part of defining the relation is that what is the action that is to be taken on the relation that is being defined, or the instance relation data, when such a thing happens. Okay. So, there are 3 possibilities. So, these actions to be specified have these qualifiers, because only upon deletion or the modification the violation might occur. So, if it occurs due to deletion or if it occurs due to update, what should be the action? So, the three possibilities can actually be specified. So, one of them is set null, the other one is set default, the other one is cascade. So, let us look at those things. So, these are the actions that can be taken on the referencing tuple. A tuple is referring to another tuple, we call it referencing tuple. Okay. So, these actions will be taken on that referencing tuple. So, what it says, one of this first thing is set null. Set null means, this is the safest options, like, so the foreign key has certain value and due to update or delete, that particular value is now not existing in the other table and you detected this. If you detect this, the simplest thing that you can do is in the referencing tuple, you can simply convert that value to null. Simply convert the value to null. If you convert the value to null, then you are kind of breaking that link. There is no more referencing at all. It is no more referencing at all. So, that means in some situations you may favor this. In other situations you might say that set default. So, the foreign key attribute value will be set to its default value. Let us say all employees who join are first by default assigned to some department and then later changed to other departments. So, there is a default department for all employees, let us say. So, there is a default value for the department ID or the section or department ID. So, you can choose to set up that. So, in case he loses the information about, see, the employee tuple, for example, is referring to some department and then that department vanishes for some reason, and so you can set this guy to work in the default department. Let us see later, we will see how to handle the situation, kind of, right. So, that is called set default. I will take an example and illustrate all these three things. Then there is one more option called cascade. What this is a bit of a very drastic action. What this says is that if the reference tuple is deleted, then delete the referencing tuple, or update the foreign key attribute if the reference tuple is updated, propagate that update. Okay. So, this is the option. So, I will show, let us talk about these things again in the context of a example. Let us create this student, create table students. Now, we have various attributes here. Roll number, it is a fixed 8 character value which is not allowed to be null. Name is a 15 character. I am sure some of your names do not fit in 15 characters, but so 15 character, up to 15 characters are not null. Degree is 5 characters, year is small int, sex is 1 character, not null, and department number is small integer. Advisor is a 6 character field. Then the primary key is roll number, and then we have table constraints. So, these are all comma separated, just you can see. So, within the same thing there is no space separated and then comma separated. The foreign key department number. Okay. So, this department number is declared also as a foreign key and it references another relation called department, and the attribute it talks references is department ID. Okay. So, the student's department is a foreign key that references the department ID attribute in the department relation. For further details about the department. So, now here are the additional things that we specify in order to take care of the referential integrity constraint violations. What this says is, on delete set null, on delete set null, and on update cascade. Okay. So, what it is saying here is that supposing there is one Sriram whose department is 9 and for some reason department 9 has been closed, okay, God forbid. And so, what we do here is we set the student's department as null value. This fellow is now without any department. Okay. And the other thing is on update cascade, his department was actually 9, for some reason it got changed to 10, because somebody decided that we will give department numbers according to alphabetical order of the department names, so something like that happened, and so his department has now changed to department ID 10. So, what this says is cascaded, that means whoever was in earlier department number 9, you update all those fellows department ID to 10 now, which will solve the problem, right. So, that is what on update cascade, that means basically propagate the change to the referencing tuples, those tuples which are referencing this value. Okay. So, this is how you specify the actions to be taken on this table, the data of this table which is being defined, when things happen on the tables that this table is referencing. It is referring to some other tables, and if something happens in those tables, what should be done here? Okay. That is what we are specifying here. So, in case something happens in the department table, what should be done for the department number attribute in the tuples that exist in the student relation. That is what we are specifying. Okay. The other is foreign key. Other foreign key is advisor here. Advisor references a professor table and specifically the employee ID attribute there. And again same same actions are found suitable here. So, for some reason somebody's advisor leaves the institute, he may be set it as null advisor as of now. Somebody should figure out that this guy does not have an advisor, and then dean's office will wake up one day and then try to fix an advisor for this particular person. Or if the advisor, for example, changed from one department to another department, okay, and then his employee ID for some reason changed, then propagate that employee ID, propagate, update, cascade. So, that is what we are specifying in as to. So, these are very important and interesting actions that we can see, because these are kind of structural constraints. We have this ability to kind of tell as to what should happen when these constraints are violated, and that is given as part of the definition of the relation itself. In the schema definition, we set up these actions also. Okay. So, that is the example. So, if you want to now go back to this thing, so these are the 3 actions that can be. So, these of course, these actions are specified for each of these foreign keys that are there in the independently. For each of the foreign keys that are there in the relation that is being defined, you have to set up all these referentially triggered actions. Okay. Any questions there? So, you can set up on delete cascade, it is a very drastic option. on delete cascade. So, a student is referring to some advisor, when the advisor leaves, then you say that drop the student also. It is a very drastic action. So, you should be careful while specifying on delete cascade, because if the delete cascades to other tuples, then we will lose lot of data. It might be appropriate in some cases. For example, let us say we are keeping track of the information about the dependents of an employee in a company, and the employee leaves the company. If the employee leaves the company, I do not have any incentive to keep track of the information about the dependents of that particular employee anymore in my company database, and so I might use this option of on delete cascade while I am specifying the dependents. While I am specifying the dependents in the dependents table, well, the dependent, each dependent tuple refers to employee tuple, and in case employee leaves, drop the dependent also. So, that is an appropriate. Okay. So, these are the various actions that you can specify. Now, how do we modify a defined schema? So, there is a command, there is a feature which allows you to kind of change the table. So, alter table command can be used to kind of modify the schema by adding a new attribute. So far we did not have address in the student. So, now we can say alter table student relation add is a keyword, the address attribute with its data type. Now, you might wonder actually what happens to the data. So far we had some data and in which the address attribute was not there. So, now we are trying to add this address attribute. So, it is a issue as to how to pick up address values for all the existing tuples and then etc. So, schema modifications are pretty messy actually. So, you should avoid them to the extent possible, but in some rare cases that you may want to really record additional information which was missed out while the design phase was going through, you may want to do this. So, there are commands for doing it, but it is going to be pretty messy to handle the database instance during this schema modifications. Okay. So, alter table add a new attribute, and deleting an attribute is also possible. You no longer think that it is appropriate to keep some information about certain entities. So, if you delete an attribute, what you need to also specify as to what should be done about the various views or constraints that refer to the attribute being dropped. Okay. Now, though I did not talk about it in the table definition in the SQL standard, it is also possible for you to kind of give a name for this constraint. See, this is a table constraint, right? So, you can give a mnemonic name for that particular constraint. Okay. So, then you can later refer to that constraint and then say that drop that constraint. Okay. Okay. So, when you are deleting an attribute, it is possible that that attribute is being used in some views or it is being used in some constraints, etc., and you need to kind of specify as to what should be done for those constraints or views. So, again there are two possibilities. The cascade is a drastic option, delete the views or the constraints also. In case you are dropping an attribute, if there is any constraint or a view that is referring to this particular attribute, simply drop that also. That is this option. There is another option called restrict. What it says is that even though the delete request has been made, do not delete the attribute, if there are some views or some constraints which are referring to it, they are using it, some constraint and some view is using this attribute, then go back to the person who has given that command and then say that this is being used somewhere, do you still want to delete it, drop it. So, this is a safer option, restrict, then you will, the system will prompt you back saying that it is being used somewhere and do you really want to drop it. So, the command is alter table student drop degree restrict, you want to some attribute, I am dropping the important attribute. Of course, in a similarly an entire table definition can also be deleted and all that. I have anyway in some sense reached a logical point where we can take up this discussion about the important very nice features of SQL. So, we will start doing it in the next class.